would like to apologize. I'm preparing my slide in Thai during for the Chinese and language. I'm Yuttana from Chiang University, Chiang Mai. Today I would like to update you in terms of the basic concept of the solar energy to produce the sun energy to the electrical, to the electric energy to the grid and standalone application. It's just only the basic concept of the solar cell application and also second presentation about the direction of the solar energy application in the 20 minutes. There are 5 topics. The first, the body the solar, then the standard of the Thailand standard and global standard, and the topology of the solar system, especially the inverter chopper, and also the important criteria is the maximum power package to capture the maximum power energy from. This is the potential of Thailand for produce the energy from the light sun. Then you can see here, Thailand is a very potential to produce the energy from the solar. And here show you the best theory of the solar or photo-voltaic to produce the energy by using the power electronic. There are 2 parts. The first part is the DC to DC converter, and the second part the DC to AC converter, as it generates the DC energy to the AC energy into the grid system. They are applied for the single phase or 3-phase application. So this is for example in my home at Chiang Mai to the first meter to deliver the energy from solar into the grid. This is the inverter from the big band inverter in the world, and is the SMB, the example or the meter to show the energy from produced from the solar into. Again, this is my house. So installing the solar in the rooftop, and some installing from technical engineering by me to convert the TV power into the AC by inverter. And this is the first thing of the electrical engineering, and drawing the second line diagram from the solar and convert to the energy to the grid. This is the PV array here, and the junction block into the DC part of input of the inverter and AC into the grid. The right hand side, the right hand side for the 250 kilowatt, the left hand side for the 10 kilowatt. For example, again this is the example. This line shows you the basic concept of the solar cell generate the electric energy. It looks like the PN junction of the diode, and here very important part of solar cell, the first cell, and then module, and then array is the solar panel to generate the bigger voltage and current in DC of the from the sunlight. Of course, there are 3 types of the material. First is the thin film. The second is polycrystalline. The third monocrystalline. The main challenge of 3 kinds of the material is efficiency. We focus to the efficiency. Here, there are 2 efficiencies. The first one is the cell efficiency. The second one is the module efficiency. It's around 15%. The main challenge is how to increase the efficiency of the solar module, cell module, and array. That's the direct research in currently. And here, it basically of the characteristic of the solar cell. In the x-axis, show you in the detail or voltage is called VPV. In the y-axis, show you in detail of current. It's very important. The current from the 0 to the top circuit current. This is the maximum current of the solar cell. Then the point here, the maximum current is for the voltage of the solar cell is 0. How about the power at this point? Of course, the power is 0. No produce the power. This means that the solar cell is the current source. They can short circuit in the terminal of the solar cell. That's the current source. It's one thing of the characteristic of the solar cell. I would like to skip complex question here, but the focus only on the nonlinear system. When in the nonlinear system, in the current of the solar cell, that's the temperature. When the temperature is increased, then the temperature increase, especially the dune, the afternoon, the temperature increase, especially in Thailand area. The current is decreased. I don't want the current is decreased. I want the current is very high. But the current is the main factor of the source cell. This slide show you the detail of sun intensity. Show you on the picture of the left-hand side, and the right-hand side of the picture show you the detail of the effect of the temperature from low temperature to high temperature on effect on the open voltage of the solar cell. It decreased from 1 to 0.8 in per unit. What about the current? A big effect on the current bus, the big effect on the voltage. It's very important to produce the power of the solar cell. This will show you the detail of the power of the solar cell in the left line. We want to get the maximum power for short MPP. In this picture, show you 3 points of the NPP here and here and here. It depends on the temperature. When the temperature changes from low temperature to high temperature, the maximum power are changed. Here, we want to capture the maximum power. The main question is how to do that. We want to use the algorithm or the maximize algorithm by using is called the MPPT or maximum profile tracking. There are a lot to capture maximum energy. The main second problem of the PV is the Partian. What is Partian? Partian is partial shading problem from the sun. The shadow over the PV panel that the Partian problem. What is the Partian? What is the important? Is reduce the power of the PV panels. It's why the Partian effect. The big question is how to solve that, how to address them by using the simple method, by using the diode connect in parallel the cell to bypass the current. It's very simple in the PV to solve the Partian problem. The second problem appears when we use the diode in parallel the PV cell. What is the second problem when we use the diode in parallel the PV cell? The maximum power tracking is maximum power. There are 2 power here and here. We want to know the maximum power we want to know the maximum power point. How to do that? How to solve that? How to get the maximum power right here? We use the special maximum power tracking, or we use the reconfiguration of the PV string and inverter to solve that problem. That's the direction to solve this problem. Down to maximum power MPP1 and MPP2, we need to know that point. Regarding the application of the PV system, there are 2 major applications. The first one is called on-grid application. The second one is the standalone off-grid application. But the power of the standalone application is around 1 kilowatt, and the on-grid is allowed, I think, currently is allowed megawatt application in the landshore. This is for the example to apply to traffic and pump application in the DC pump and AC pump and battery storage application. This is for the diagram for the grid application. We focus to the high quality at the DC, the AC side. In the standard point view, we focus on the waveform quality when we input the voltage and current into the grid. We focus the standard waveform quality. What is the indicator of the waveform quality? The indicator of the waveform quality is THDV and THDI. This means that we need to low harmonic distortion into the grid system. So this is standard based on IEC standard. It depends on the power scale of PV application. The main problem in Thailand, what is the standard in Thailand based on PV application? The question and the answer is grid code standard in Thailand. We are member of the PV application. We following the grid code standard in Thailand. If we are the owner, we must concentrate on the cost and the efficacy and the aging of the PV as a cap. There are 3 points to focus the PVs. Okay, the direction, one of the direction of PV application is the EMI with PV pan application. There are four parts. The first part is PV, and the second part is the DC link application at the point B, and the third part is the inverter, and the last part is the connecting into the grid. Why we focus on the PV system we connect to the grid? The answer is the EMI problem. The event the PV connect into the grid with the high frequency application. What is the high frequency application? Who generate the high frequency application? PV or not? No, not PV. The high frequency application with high frequency generated by the inverter. The inverter generates the EMI problem. Of course, we want to choose the good inverter we use the PV system. Would you like to skip this? Okay, move on to the inverter topology technology. There are a lot to inverter technology. I would like to introduce for example. The first is the single state configuration. Here, the single state configuration with the maximum packing algorithm, including the inverter state. And the main function of inverter have the PV, the PQ power or current power control to control the reactive and active power into the second is called dual state. The dual state is the DC to DC converter in the first state. It connects between the PV system and the DC link system. The next state is the inverter. It's called dual state configuration. And here, this diagram show you another inverter PV application. It's called dual state with common DC AC inverter. You can see here, it can separate the PV system into the two groups. The first group is the PV connect to DC converter, and the last group is the other group is the PV and DC to DC converter. But the output of both converter is the DC. You can control the output of DC and here to contact, and then to convert to AC to the grid. They are applied for the single phase and three phase application. Okay, how about the isolate transformer? Of course, there are two types. The first type is low frequency transformer. The second type, the high frequency transformer, to apply for the PV system is used in the USA application, but the cost is very high. Why using the USA application in the area of use of the USA or the Canada? It concerns the ground effect. How about the Thai? No, it will come for Thailand. Ground or no ground, it will come in Thailand. For example, for the high frequency application, what is high frequency generate from? The high frequency generate from the input side of the converter from DC to AC inverter in the high state and operate at a high frequency, and then convert to the AC to AC again into the gate. For example, this is called the high frequency link or AC link application for the PV system. For example, with transformer-less configuration, we want not to put the transformer to the PV system due to the cost. We don't want to pay the high cost of PV system. I want to introduce you the name of standard PV inverter in detail. The first is Centon inverter. What is the Centon inverter? The Centon inverter is the single PV and single power converter and single skid. This is the Centon inverter. Show here. This is to show the detail of Centon inverter, PV side, and one converter into the grid. How about this? This is the string inverter. There are three string inverter. We want to manage string inverter? Yes. What is the benefit of string inverter? We can use the multiple maximum point tracking operate to capture to maximum power the PV. When we compare the efficiency between Centon inverter and string inverter, of course the string inverter very best to choice to the PV application. How about this? It is a circuit in the PV system. In the string inverter, there are two designs. The first design, I call design A here, by using the DC to DC converter, use the flyback converter, double end inverter to convert the DC to high frequency DC and convert the DC to AC into. How about this? With the design B, we use the non-isolated DC converter, like the boost converter put here between the PV system to generate the high voltage DC from DC voltage to the DC link before convert the DC to AC again into the grid. And here show the multi multi-sting inverter. The main question is what is different the multi-sting inverter and sting inverter? The multi-sting inverter, the output of the multi-sting inverter of the DC inverter is the DC. We mix between the senton and sting called multi-sting. We use TDC to DC converter and one common senton inverter. This is called the multi-sting inverter. It's really the same between the sting and multi-sting inverter. This is the example of the multi-sting inverter. The multi-sting inverter use the common DC link. Use the common DC link here. Before convert the DC to AC, we can use the single phase or a three phase for application. We can use the two level or multi level of inverter application. This is very popular currently now. Is the multi-sting inverter in the market now. And here again is the multi-sting inverter. In the 2020, we have a new model. It's called AC module. What is the AC module? The AC module is the module integrated inverter. We use the single panel, the single inverter apply general test for the standalone application. For the kit application, unfortunately, the power is the limit of this AC module application. This is for example AC module. You can use here the AC application. For example, 500 watt. We can use 500 watt here and 500 watt here and 500 watt here. The sum of power allow 1.5 kilowatt here. This is the proof of the AC module. You can connect here into the kit directly, or you can use it here for standalone application. This is the AC module or module integrated inverter in Thai inverter ผสมผสาน or hybrid inverter. This is popular now for the PV application. I want to promote, I want to vote the AC module to apply to anywhere, any place for PV application due to the cost. This is the same example of the circuit of a PV module. Of course, standard of the power electronics, we use the single or two state for the picture. For the two state, the first state for convert the DC to DC to up the voltage here from the low voltage of the PV to the high voltage of the DC link before convert to AC again to DC. Connect power into the gate. Okay, this table shows you the detail of the summarize of the property of inverter for the PV application. Of course, the type of the inverter, there are the common four types. The first senton inverter, sting inverter, the multi-sting inverter, and AC module. And you can select based on the voltage of PV panel in series in parallel to get the power length. You can select the power length, the cost, and control here low, medium, high, and advanced, and this and the average and different and the high of the switch application in the inverter. Okay, again, this shows you in terms of simplify of the inverter PV system, both senton, sting, multi-sting, AC module. AC module is really interesting in right now. And I share the sting for the and short application to the bigger power. And multi-sting is the best, one of the best choice from the sting and multi-sting. I think it's the same. Okay. Regarding the algorithm, when you buy the inverter, it must be include the maximum Photo-voltaic function. This is the main function of the inverter when you buy the inverter for application to get the maximum power. There are many maximum Photo-voltaic methods. This is show you the algorithm. It's called the PO algorithm, open and short circuit algorithm, and connect algorithm by using the impedance changing. It's called the connect algorithm. Different MPP algorithm, fuzzy logic algorithm, focus on the maximum point to capture the maximum power from the MPP algorithm to control the inverter to capture the maximum. You can get information from the PV side on the AC side. In generally speaking, currently we use only the input side voltage and current of the PV to information of the MPPT algorithm to control the inverter. And here, when we use the sting inverter, we can use the three maximum Photo-voltaic separate control one by one of the work. And here, from the multi-sting, we can use Chi algorithm to control the converter. But we use only the DC to DC converter, not the DC to AC converter control with the MPPT algorithm. So I want to conclude my statement. Okay, when we want to apply the PV application, I think it should be focused T and 4 points. The first point to increase the efficacy of the inverter. The first point is MPPT algorithm of the PV of inverter. And the second point is the high quality waveform at the AC side into the kit application. The third point is efficacy. Efficacy is the ratio of the power out and power in. It is the efficacy of the inverter. And then in point of view of owner is the cost. There are 4 points when you select the inverter for the PV application. That's all my presentation.